This is a personal sauna. The recommended operating temperature in most parts of the world is between 150 and 175 degrees Fahrenheit, or 65.6 to 79.4 degrees Celsius. But in Finland and other parts of the world, the upper temperature is generally recommended up to 212 degrees Fahrenheit or 100 degrees Celsius. Ah, comfy. This is a range with stove on top and oven on the bottom. You probably have one in your kitchen. Imagine that I have a pot of water boiling on the stove at 212 degrees Fahrenheit, 100 degrees Celsius. What would happen if I put my hand in there? I'd have some serious problems and would probably be going to the hospital, right? How about the oven? If I had the oven at 212 degrees Fahrenheit, it would be the same temperature as that Finnish sauna. I could actually climb inside and be perfectly fine as long as I didn't touch anything metal in there. Why is that? The explanation is simple. Water is about 784 times more dense than air at sea level, so there are more particles available to transmit that heat compared to air. The less dense the air, the less efficiently the heat can be transmitted. This is why you sometimes see labels on food similar to this, because the air density drops substantially as you gain altitude, with almost all of the air being only a few miles from the surface, so it takes longer to transmit that heat to the food. Because of this, cooking times or temperatures need to be adjusted at higher altitudes. At 23,000 feet, 7,010 meters, the air is about 50% as dense as it is at sea level, while at 50,000 feet, 15,240 meters, it has dropped to only 15% as dense. By the time you get to around 30 miles, 48.3 kilometers up, the air density is less than 0.1% of what it is at sea level. At the level of even the lowest satellites, 150 miles or 242 kilometers, there are virtually no air particles at all to transmit heat. This is the main reason that satellites don't melt in space. Do satellites have to contend with heat in orbit? Yes, but not so much from the atmosphere. Most of the heat a satellite has to deal with is due to radiant heat from the sun, which can be dealt with. Radiant equilibrium is the point at which the amount of heat that an object is radiating is equal to the amount of heat that is being absorbed. Satellites take advantage of certain materials and techniques that maximize the amount of heat being radiated while minimizing the amount of heat being absorbed, using, for example, multi-layer insulation composed of mylar or captain.
Hey, you guys want to see my fully working flat earth model? It's down in the basement, hold on. Oh, the light bulb blew out. Oh, that's okay. I'm sure I can find it. Oh, it's just a pie plate.